Hello everyone, my name is Prateek and I'm a freelance colorist based in India. This is the third episode in a series of tutorials called Upgrade, where I share color grading techniques and workflows I've found useful, and I hope you'll find them useful too. Today's topic will be about rebuilding the RGB curves of an existing LUT. Let's first understand why you might want to rebuild a LUT. LUTs are very powerful tools, but there are instances when you might want to have full control over the image. That's when rebuilding a LUT as a power grade will come in handy. You'll have complete control over the look and can make tweaks to it based on your needs. You'll also have the option of removing adjustments you don't like when you rebuild a LUT as a power grade. Most importantly, a rebuilt LUT using native resolve tools will not clip the image like a LUT unless it's used in a destructive manner. The first step in the process of rebuilding the RGB curves of a LUT is to add a grayscale into the timeline. You'll then have to right-click and create a compound clip of the grayscale so that it is recognized in the color page. After that, you'll need to apply the LUT you want to rebuild on the grayscale. I am going to try rebuilding the Rec 709 Kodak 23A3 D65 LUT that comes with Resolve, but you can use any LUT and follow the same steps. If you open up the scopes, you'll be able to see what the LUT is doing to each channel. I'm going to grab a still and reset the grade. We will be using this grabbed still as a reference for rebuilding the LUT. I'm going to switch to the image wipe mode now so that I have an easier way of comparing what the LUT is doing. Now, if you look at the scopes, you'll be able to see both a straight line and a curve. The straight line represents the grayscale and the curve is the manipulations the LUT produces. You can then start by using the custom curves to rebuild the LUT by matching the two waveforms as closely as possible. I always like to start with matching the contrast curve and then proceed to match the RGB curves. I prefer using the waveform for this and I choose the luminance channel only mode. When matching the curves, I'm only looking at the waveform and tweaking the curves to get a close match. Now that we have matched the contrast, we can start matching the RGB channels in a new node. An important thing to note when matching the RGB curves is to have the Luma mix set to 0, so that the channels behave independently to each other and don't compensate luminance. We have already matched the contrast curve, so we only need to match the deviation of the RGB curve from the main curve. When matching the RGB curves, you can change the waveform settings to display only the channel you want to recreate. I'm going to start by matching the red channel and then proceed to match the other channels. It's totally up to you how accurate you want the rebuilt grade to be. You can finesse the curves to match it as close as possible. You might have to go back and forth and make some tweaks throughout the process. Now, we have successfully rebuilt the contrast and split toning of the LUT. You can test how the rebuilt grade works on different types of shots and compare it to the LUT and make some changes if needed. You can save this as a power grade and use this in your future projects too. So that's how I like to rebuild the RGB curves of a LUT. In a future video, I'll show you how to rebuild the hue components of a LUT too. Let me know how this technique I demonstrated in this tutorial works for you. If you have any requests for other tutorials, feel free to drop them below.